The operations manager is a part of the product design team. He is fully responsible for process selection. Now we are moving to process selection. As you are going to be the operations manager, because the course is offered to know about the operations functions of the company. The operations management course is designed to know more details about the production department. So here, process selection, the main role of the operations manager. Product design is related with process selection. What are the common types of process? There are two types of processes. One is intermittent process and another is repetitive process. And this is also known as, extreme, too extreme. One is intermittent. When you are going to a tailor, in this Eid, many of you will go to your tailor, and I will also go to my tailor. See, the product that will be produced for you and the product that will be produced for me will be same or different. What do you think? You're not listening to lectures. What do you think?
Mm.
The product,
Also,
I will go to tailor. The tailor will produce my shirt, and you will go to your tailor. The tailor will produce your dress, your shirt. The product will be same or different.
so the product will be different.
Totally different, because the specifications are different. The design is different. When the company is offering different products to different customers, it is known as intermittent process. Processes used to produce a variety of products with different processing requirements in lower volumes. So your one shirt is going to produce, my one shirt is going to produce. When you are going to medical doctor, the healthcare facility offering to you and the healthcare medication offering to me is different. This is known as intermittent process. And the another process is known as repetitive process. Processes used to that standardized product. Just we have finished the definition of standardization. Here, repetitive process is ultimately a standardized process. Processes used to produce one or a few standardized product in high volume. That means when Toyota designs a car, it produces a huge high volume of same car. High volume of same car. These are the two processes you can choose. So when the number of item will be few, you will use intermittent process. When the number of item will be high, you choose repetitive process. All right. So product design considerations must include the process. That is important, because our chapter title is product design and process selection. So product design considerations must include the process. Differences between intermittent and repetitive operations are the amount of product volume produced and the degree of product standardization. So when you are producing low amount of product, you are using intermittent process. When you are producing high volume of standard product, you are using repetitive process. And processes type can be project process, batch process, line process, continuous process. What is project process? Padma bridge production process. Padma bridge construction process. Is it repetitive or is one-time activity? It is one-time activity. When you are producing only one product one time, that you are not repeating, this is known as project process. This is known as project process. Make a one at a time product exactly to customer specification. Pot the brace. Batch process. When you are producing a small quantity of product in groups or batches based on customer orders or specifications, this is known as batch process. If you have the options to go to pharmaceuticals companies, textile companies, you will find that batch process is very popular. Say for an example, in garments production, they use batch processing in washing. When they wash the garments, they use batch. When they dye the product, the coloring, dye the product, they use batch. Because one batch components will have separate specifications. And then line process. If you go to Walton, if you have the chance to visit Walton, you will find that the air conditioning production line, because they do not produce the parts. They buy the parts and they assemble the parts in production line processing. Large quantity of a standard product. Refrigerator is a standard product. So they are producing refrigerator in a line process. And continuous process means that if you visit Coca-Cola factory, you will find that they are producing 1 liter in a production line and forever one product. High standardization, continuous process. A very high volume of a fully standard product. So they apply a real continuous process. If you go to Coca-Cola, if you go to Toyota, Mercedes-Benz, then you will find that they are using continuous process. And that means product standardization. The higher the product standardization, the process is going higher the product volume, more product standardization, you are using continuous process. You are using line process. You are using batch process or project process when the product is very low standard and the volume is also low. So when the product volume will be high, product will be very standard, then you will use continuous process or line process. The continuous process is the extreme of huge product and high standard product. Coca-Cola, Pepsi, their production process is continuous. Water treatment plant, Aquafina, Pepsi's water product. Designing process. When you are designing the process, you have to draw the flowchart. What are the steps? So first is cutting, then sewing, then finishing. So a full analysis of the production flow, process flow. And after cutting, it will go to sewing section. After sewing, it will go to the finishing section. A full process flow analysis is very important for designing the process. And you will have a production flow chart. And design considerations includes when you are delivering the product. You can choose several strategies. It may include make to stock strategy. That means you will manufacture the product and you will store in your inventory. And when the customers will demand, you will deliver the product. This is known as the make to stock strategy. Then assemble to order strategy. That means you will all the components you will make ready And when they will place the order, you will deliver the product. Say for example, if you go to Apple Store to buy a MacBook, say for example, then they apply both the strategy. There are some ready product you can buy from the outlet, ready-made. Just you will make to stock. The products are available in their stock. You will you will go and take the delivery, pay the money. And they have also assembling options to assemble to order strategy. What is it? If you go there and if you say that I need 512 GB RAM, 1024 GB storage capacity, maybe it is not available in their stock. So what they will do, they will take the notes from you and then they will send to the back store. The back store will rearrange the product and they will deliver the product. It is known as the assemble to order strategy. And sometimes it is make to order. Make to order means that you will place the order, they will make the product, and then they will deliver. Our garments production in Bangladesh. Make to order. Your dress from the tailor. Make to order strategy. So you will make order, they will produce the product, and then they will supply the product, finished product. So the operations manager can choose any one of the or all of the strategies to satisfy the demand, and this ultimately depends on the product nature, volume of the product, standardization of the product. See flowcharts for different product strategies of Antonius Pizzeria. Next slide. Okay. So here the make to stock strategy, assemble to order strategy, make to order strategy is given here. So this is a pizza. Think about the Pizza Hut in our country. What they do in make to stock strategy. So here is the customer order. When you will place the customer order, the product are ready. Finished goods are available in their inventory. They'll deliver the product. It is known as the make to strategy. That means the company will make the dough, prepare, crash, assemble pizza and bake the pizza and will make it ready for the customers. So when the customers will place the order, they will deliver the product. It is known as the make to stock strategy. So customer receives delivery after ordering the product. Assemble to order strategy. What is it? Ingredients, dough, crust, all are ready, but they are all ready. The assembling will be done after getting the order from the customers. Maybe the customers are ordering more cheese or extra cheese. Maybe they're demanding something that is not available in the stock. They're demanding beef and chicken together. If the stock is not available and the order is little bit special, what they will do, this is common. This is common. The working process is ready. Only some components will be mixed with it and then they will bake it, then deliver it. This is known as assembling to order, assemble to order strategy. And the strategy may be make to order strategy. That means you will go to the Pizza Hut, pizza shop, and then you will place order. And you will say that dough must be thin, or dough or the crust must be thin. So when they are preparing thin crust, what they have to do, the dough will be different. So the operation will begin from dough preparation and then crust, then assembling the pizza, bake, and delivery. That means you are receiving the order at the beginning of the manufacturing point. Here you are receiving the order at the middle of the production process. Here you are receiving the order after manufacturing process. So you can choose any one of them or all of them, but it depends. If the product you are producing a standardized product, then make to stock. Make to stock. If you are producing assembling like MacBook, Apple, or like in our country Walton, they you can place the order and they'll assemble the product and they'll deliver the product. Or you can demand, if you go to the tailor, then the production will begin from the very beginning of the total process. After receiving the order, production will begin. The garments production in our country is make to order strategy, because after receiving the order, they check the design, they confirm the design, they develop the samples. After approval, after approval of the sample, the production begins. The make to order strategy. So these are the production operations strategy you can choose, and these are the foundation of our production management. And when you are manufacturing a product from beginning to end, you will check the metrics, whether your production is going smoothly or interruptions are there, possible problem area, problem area, problem area. So you have to check it thoroughly. The whole time from beginning to end is known as throughput time. A basic process performance metric is throughput time. Throughput time means the time takes from production begin to production end is known as throughput time. A lower throughput time means that more products can move through the system. So if your total production time is minimum low, then your production, say for example, if your production, if it takes 1 minute to produce a product, you can produce 60 product in a minute. But if your throughput time is 30 seconds, you can produce 120 product in a minute. Are you getting? Oh, sorry, 120 product in an hour. So if your throughput time to produce a product is 1 minute, then you can produce 60 units in an hour. But if your throughput time is 30 seconds, you can produce 120 units in an hour. So a lower throughput time means that more products can move through the system. That means you can produce more items. One goal of process improvement is to reduce throughput time. Reduce throughput time. And process performance metrics using throughput time. Measurement of different process characteristics that will tell us how a process is performing. Your process is better or your competitor's process is better. How you will say that? You will analyze the throughput time of both the companies. Or parallel in garments factories, they run few production line together. One production, two production line, third production line, fourth production line. So which production line's throughput time is lower? That is the best production line, process performance metrics, throughput time. And using this throughput time, we can calculate several metrics. These are the process performance metrics. Say for example, in production line, there are 4 In a garments factory, there are 4 production lines. If there are 4 production lines, what you will do? You will calculate the throughput time of each production line. That means, what is throughput time? Time takes from beginning to end of manufacturing the product. Average amount of time product takes to move through the system. And you can calculate process velocity. Process velocity equals throughput time. Total time takes from beginning to end. Throughput time divided by value added time. And now the problem is that what is value added time? Value added time means that actually how long does it take to finish the product? Throughput time, say for example, in a garments production line, it took 10 minutes. Throughput time is 10 minutes to produce a product. But value added time, actually, the workers went to washroom. Average washroom time is 1 minute. There may have machine breakdown problem. On average, say for example, we found that the machine breakdown time is another 1 minute. Another problem is the raw material crisis. Raw material was not available on time. So there are 3 minutes wastage. Are you getting my point? 3 minutes wastages are there. So this is known as allowance. In operations management language, this is known as allowance. Allowance is 3 minutes. Allowance is 3 minutes. So value added time is 10 minus 3 equals 7 minutes. Are you getting what is value added time? Throughput
Yes,
time
sir.
minus the allowances. Allowances 7 times. So your throughput time is 10 minutes and your value added time is 7 minutes. 10 divided by 7. It is more than 1, isn't it? It is more than 1. So process velocity here is more than 1. But if there is no allowance, no machine breakdown, no extra time, then what will be your value added time? 10 minutes, isn't it? So your value added time and throughput time may be equal. In that case, it will be equal 1. 10 divided by 10 equals 1, isn't it? So it is the perfect,
And জামাইছো জানো
it is ultimately the, process velocity that operations manager always think of, making it 1. It cannot be less than 1. Can it be? Because your throughput time is 10 minutes and there is no allowances. That means allowance cannot be minus. Allowance be minus? It cannot be minus. That's why your throughput time and value added time may be equal. Equal, in that case, your velocity will be 1. It is the perfect process matrix. So when your process velocity will be 1, you will say that there is no allowances and all time is value added time. So your actions will be to reduce the throughput time. It is known as the process velocity, and you can measure the process performance by using productivity. Output divided by into. If you 4 production line, you will calculate the productivity of 4 production line. Output divided by input. Then you will get another performance matrix, process performance matrix. You can also calculate the utilization. Utilization means time or resource used, time or resource available. What is it? Say for example, you have bought a machine. The machine capacity, say for example, washing machine. Your washing machine capacity is 10 kg, 10 kg. But on average, you you are using every day you are washing only 5 kg. So 5 divided by 10 equal 50%. Your utilization is 50%. Are you getting what is utilization? And in production process, say for example, a machine, or a dyeing machine, say for example, in a garments company, or a washing machine in a garments company, or a spinning machine. A spinning machine has the capacity to produce 200 units. Capacity is 200 units. But on average, you are producing 100 units. 100 units. So what's your capacity utilization? What's your capacity utilization? Capacity utilization is 50%. Are you getting what is utilization? And
Yes,
efficiency
sir.
means actual output divided by standard output. This is your efficiency. What is, say for an example, actually a worker producing 10 units, but average output from the other workers, that means the standard output is 12. So what is the efficiency of that particular employee? 10 divided by 12. Are you getting? So you will compare here actual output and standard output. The standard may come from the other industries. Your factories worker are producing 10 units, but other factories, similar type of factories, is producing 12 units per day. So efficiency of your factory will be 10 divided by 12. That means actual output and the standard output. So these are the process metrics you can use to measure the process performance. Process performance. Are you getting what is throughput time? What is process velocity? What is productivity? What is utilization? And what is efficiency? This is also the components of the operations analytics. Operations analytics. We are doing some operations analytics. That's why the lecture that we are uploading for your future was, we rename it as operations analytics. All right. And this is also an example. So use your mobile phone and or calculator and paper to calculate the process velocity, labor utilization, and labor efficiency of the company. So try it now. Miss Anika. Anika today is absent-minded. He is doing some other jobs. Sirajum Monira, please. Can you please
Yes,
calculate
sir.
process velocity? Especially
Process that.
these were your class test. We summarize the slides based on your class performance measurement. But as the lecture we are delivering in online, that's why we are facing problem to conduct the tests, because IOB doesn't allow online tests, any type of online tests, and that's why I'm not taking any tests. Jelly's Dry Cleaners, as Mr. Munkase, please take care. Jelly's Dry Cleaners has collected the following data for its processing of dress shirts. It takes an average 3.5 hours to dry clean and press a shirt, with value added time 110 minutes per shirt. So what is the process velocity? Here, the average time is 3 hours and 30 minutes, isn't it?
3.5. 3.5.
3.5 converted into minutes because valued time is given
Converts
in
into
minutes.
minutes.
So what
Yes, sir.
minutes? 180 plus 30. 210 minutes, is it?
30.
210
Yes, sir.
minutes. So 210 minutes is
10.
your throughput time. Throughput time 210 minutes divided by 110 minutes is equals what? Is your process velocity. Throughput time divided by value added time. What's your throughput process velocity?
So 23,100. 23,100.
No. 210 divided by 110. 1.90. It will be around 1. When it will be equal to 1, it indicates that the process throughput time and value added time is same. All right. 3 hours
Sir, I
and
didn't
30
get it.
minutes.
The 3.5 thing. Sir, the measurement I didn't get it, sir.
No. It is not 3 point. It is hours and 110 minutes.
Hours.
So you
110.
convert hours into minutes. 3 hours equals 180 minutes plus half hour
180
equals
minutes
30 minutes.
plus 30 minutes.
210 minutes. 10
200
minutes divided by 110 minutes equals 1.9. Your process velocity is 1.9. And your labor utilization.
1.9, sir.
Labor utilization means that workers are paid for 7-hour workday and work 5.5 hours per day on average. That means payment is done for 7 hours, but they're actually doing 5.5 hours on average. Accounting for breaks and lunch. Labor utilization is 75% in the industry. So you have to compare with the industry and what about your case? Here, how to calculate labor utilization? Labor utilization, how many hours they're usually working? 5.5. You can here write 5.5 because this is also given in hour. 5.5. 5.5 divided by 7. All right, or you can convert it into minutes. So if you use hours, then what will be your percentage? 5.5 divided by 7 is your labor utilization. What's your labor utilization rate? What's your labor utilization rate? $5.5 divided by 7.
So 0.78.
Sir, 0.78. 0.78.
0.78. 7 divided by
0.78, sir.
5 and 5. Divided by 7. Okay, 7, 8 or 79%, is it? Your labor utilization rate is 78.5% or you can say 79%, is it? But the industry average is 75%. So you can say that your labor utilization rate is better than your competitors. Are you getting? Labor utilization in other firms, that means in the industry, is 75%. And your labor utilization rate is 78.5 or 79%. So your labor utilization is better than other companies. The dry cleaner completes 25 shirts per day, actual output, with an industry standard of 20. So standard output is 28. And you are producing 25. What is the efficiency for your company? 25 divided by 28. What is your efficiency rate? 25 divided by 28 is 89% efficiency compared to standard. So you have to bring it up to industry standard. That means 100%. You have to try to convert your efficiency level to 100%. 100%. So process velocity is 1.9. Labor utilization is 78.6. Efficiency is 89%. Process velocity shows room for process improvement because 1.9, you have to bring it down to 1, as throughput time is almost twice that of the value-added time. Labor utilization is just above the industry standard, though overall efficiency is below. So the conclusion is that although labor efficiency utilization is above than industry, but it is less than industry standard. So you have to take care of the labor efficiency. Although they're coming 5.5 hours in the office, but they're not doing their right jobs properly. So that's why you have to take care of the people who are working in your factory. These are the process metrics. You have to take care of the process metrics. Some more concepts are given, and the concluding word is that you have to link your product design with the process selection, because product design will help you to choose the process selection. Product design and process selections are directly linked. Type of product selected defines type of operations required. Type of operations available defines broader organizational aspects such as equipment, whether equipment is available or not, facility, whether the facility is allowing your production, where the organizational structures support you to produce that product. So you have to link your design with the manufacturing process. And in today's world, in the age of 4IR, fourth industrial revolutions, you have to take care of the technology also. Say, for example, you are working in enterprise resource planning platform. Global positioning system is there. You can monitor the performance sitting at home. RFID radio frequency identification number is given to each and every component of the manufacturing process, because when you are transferring one product to another product, you need to check what type of product, where it will go. If you scan it by using RFID, automatically this will go to the right track. So I have some experience of working in a manufacturing company in another country, and I found that RFID is very effective for managing production flow. So the RFID system is scanning the product, and the automated system identifies whether the product will go to the right track or left track. And these are automated system. And GPS there are many factories. Say, for example, in Bangladesh, Coats is producing garments thread. Coats, their machine is connected with GPS system. You can monitor the performance of the employees. For IR or IoT, Internet of Things, IoT devices are attached with the machines. They can check whether the machines has any problem or not by sitting at home or even at head office. So automation is the timely action, and AVG, ASRS, FMS or flexible manufacturing system, robotic systems are there. In Toyota, I found that robotics operations are very effective, and robots are, say for example, a hand door, door of the car. So if human handles it, there may have a lot of problems. So robot handles it. How the car door will be fixed. The robotics applications are very effective. Computer-aided design, computer-integrated manufacturing, these systems are available in today's world. So what you have to do, you have to cope up with the coming